So what we're going to do now is we're going to find the attributes of these quadratic functions algebraically. What that means is, what if you're not given a graph? What if you're given an actual equation? You don't have to actually graph it yourself to find things like the vertex or the y-intercept. You can do it using the function itself. So first of all, let's review. So standard form of a quadratic function is y equals ax squared plus bx plus c. A, b, and c are all just numbers, okay? So in this table, we have how to find all of our attributes, all our characteristics. So the first thing we have is the axis of symmetry. Okay, remember, that's the line that goes right through the center of your quadratic and cuts it directly in half. Here's the formula to find the axis of symmetry. It's always x equals, remember, because it's a vertical line, negative b over 2a. That's how you find the axis of symmetry. So you're actually going to use a and b from your standard form equation to plug in this formula. Okay? Now remember, the vertex and the axis of symmetry are related. The axis of symmetry runs through your vertex. So in order to find the vertex, you first have to have the axis of symmetry. That's what step one is. Find the axis of symmetry. Okay? This is the x-coordinate of your vertex. Then you're going to substitute whatever number you get here into your equation, simplify to find the y, and then write it as a coordinate point. Don't worry, we're going to go through an example with all of these pieces later. So for the y-intercept, all you have to do is, well, substitute in x equals 0 into your equation, because that's how you define a y-intercept, is where x is equal to 0. Simplify to find the y-coordinate, and then again write it as a coordinate point. 0, comma, some number, because the x value is always 0. Lastly, we talk about the opening direction. So sometimes parabolas open up, sometimes they open down. So the way you figure this out is you look at the a value, whatever number is next to x squared. The number itself isn't really that important right now. We just want to know about the sign. So if it's a positive a value, that means your quadratic graph is going to open upward, which makes your vertex a minimum. So if it's a positive a, your graph is going to look like this, upwards, opening up. If it's a negative a value, your graph is going to open down, which makes your vertex a maximum, which means it opens this way. Okay? So let's do an example to find all of these different pieces of a quadratic function. So here's example 1. Later at the very end, we're going to sketch it. So example 1, f of x equals 3x squared plus 6x minus 5. Okay, so we are going to first always find the axis of symmetry. So I'm going to label, make sure your work is neat and you can find it later. So step 1, find the axis of symmetry, AOS. Okay, so here's your formula again, x equals negative b over 2a. So first of all, let's label our quadratic function. So the 3 is the a, because that's in front of x squared. The 6 is b, that's in front of x. And negative 5 is your c, because that's the constant term. So let's plug in what we need for our axis of symmetry formula. So negative is just part of it. So negative parenthesis, b is actually this 6 right here. So we're going to plug in a 6 for b. So negative 6 over 2 is part of your formula times, and then a is this 3 right here. So negative 2 times, or positive 2 times 3. Now let's go simplify. So the numerator just becomes negative 6. 2 times 3 makes a 6. Negative 6 divided by 6 is negative 1. So the axis of symmetry is x equals negative 1. Here's part of our answer. Okay. The next thing we need to find is the vertex. So the axis of symmetry and the vertex are both related. So what we're going to do to find the vertex is we're actually going to use that x equals negative 1 piece. So step 2, vertex. So we remember f of x is just fancy for y. What we're going to do is everywhere we see an x, we're going to actually take this negative 1 and replace it with x, because the vertex and the axis of symmetry are related. So 3 times negative 1 squared plus 6 times, there's another x, we're going to replace it with -1 also, minus 5. Now all we need to do is we use order of operations to simplify in order to determine what our vertex, the y, is. So first we're going to square things. So -1 squared is -1 times -1, which makes it +1. Everything else stays the same. Order of operations next says we're allowed to multiply. So 3 times 1 makes 3. 6 times -1 makes -6. Drop the -5. Next thing order of operation allows us to do is combine like terms together. So we've got -6 minus 5 makes -11. And then 3 minus 11 makes -8. So my vertex then is the -1 from the axis of symmetry, comma, -8 is the y value. There is the vertex of my quadratic. Next, we're going to find the y-intercept. So step 3, find the y-intercept. And this may not even require a lot of work from you. Some of you are going to be able to find this without even having to write anything down. The x is always equal to 0 for a y-intercept. So again, plug in a 0 wherever you see x. So 3 times 0 squared plus 6 times 0 minus 5. Well, 0 squared is just a 0. 0 times 3 makes 0. 6 times 0 makes 0. Drop your minus 5. So 0 plus 0 minus 5 makes -5. So your y-intercept then is 0, -5. Okay. And the last piece we need to complete this little puzzle is we need to figure out our opening direction. Okay. So that's your a value. So for this one, we have to decide, is the a value positive or negative? So we're going to go back up to our equation. So the a value here is a 3. Well, that's a positive 3. So a value is positive, which means it opens up. And we know that because the a value is positive. Okay. Last thing we're going to do is we're going to actually go sketch this. And it's a sketch. It's not going to be perfect. It's not going to be exact. We're just going to get an idea of what this looks like. So start with that axis of symmetry. So it was -1, so that's going to be over here somewhere. So there's my axis of symmetry. My vertex is at -1, -8, so it's going to be on this axis of symmetry, somewhere about there. Y-intercept is at 0, -5, so maybe a little higher. Actually, you know what? Let me change colors and make it purple, like the work is. And then the opening direction is upwards, so it's going to hit the vertex, hit the y-intercept, and come back up. There's the sketch for our first example. So try number 2, pause the video, or rewind it to see if you can find the work. Try number 2. Okay, let's do number 2. So number 2, determine the vertex, axis of symmetry, opening direction, and y-intercept of the quadratic function g of x equals -2x squared minus 8x minus 46. So we're going to start this off the same way that we started off number 1, by finding the axis of symmetry. So, oops, here we go. So number 1, AOS for axis of symmetry. And your formula for that is x equals -b over 2a. And again, you're not going to have to memorize this formula. I'm going to give it to you if you ever need it. So x equals, let's go label our pieces of our formula here. So -2x squared, so a is equal to a -2. -8x, b is equal to a -8. Minus 46, so c is equal to a -46. Now that we have our values, let's go substitute them in. So this negative is just part of it, but b is also a -8. So right now, you do have 2 negative signs next to each other. Leave them there for now. We'll simplify them in a minute. 2 times whatever a is, and a happens to be a -2. Now let's go simplify. So when you do negative times a negative, that comes out as a +8. And then 2 times -2 makes -4. 8 divided by -4 makes -2. So your axis of symmetry is at x equals -2. Now that we have the axis of symmetry, we also can find our vertex as well. So step 2, find your vertex. This means we're going to substitute our x equals -2 in for x and go find a. So -2 parentheses, whatever x is, which in this case also happens to be -2, and then square it, minus 8 times x, which is -2, minus 46. Now we're going to simplify with using order of operations. So anything that's squared has to come first. So -2 squared makes -4. So this is -2 times -4. I'm going to go ahead and multiply this guy in since there are no exponents around this -2. -8 times -2 is a positive 16, and drop that minus 46. Then continue with your simplifying. -2 times -4 makes a positive 8. 16, I'm going to actually do plus 16 and minus 46 down here as well. And then we're going to just keep simplifying. So 8 plus 16 minus 46 makes -22. So our vertex for this parabola is -2, -22. Next thing it asked us to find was the opening direction and the y-intercept. It doesn't matter what order you actually find this in, so I'm going to do the y-intercept first. So the y-intercept for step 3, remember this means your x is always a 0. So we're going to substitute 0 wherever x is. So -2 times 0 squared minus 8 times 0 minus 46. So just like the last one, this first term ends up being a 0, the second term ends up being a 0, and all you have left is that c value of -46. So if you can see the pattern, your y-intercept is always the c value, which is why it doesn't require much work from you, because anything with an x, anything times 0 is 0, so that term is going to simplify down to nothing. Last piece we need is the opening direction. So that's step 4, opening direction. Okay, so with this one, we're going to look at that a value. So I can't see it, so I'm going to zoom out a little bit. So my a value for this one, a value is negative this time. Again, it's not the number I really need to worry about. It's whether it's a positive number or a negative number. So because the a value is negative, what that means is, that means your parabola is going to open down. So it's going to look like this on your graph. Now that we have all of our pieces, let's go ahead and make a sketch. And this one has to be a sketch because you've got two pretty big numbers. You've got -22 and you've got -46. So this definitely has to be a sketch. So it's not going to be completely accurate. So again, axis of symmetry, start there first. X equals -2 somewhere over here in the negative x area. Your vertex is going to be -2, -22, so somewhere way down there. But then look at your y-intercept. It's 0, -46. Well, that's even further down off of my graph because of the way I drew it. Okay? And then number 4 says it's going to open down, so it has to look like this. If you have a y-intercept above your vertex and it opens down, something happened because you have to be able to hit all of this stuff. Okay? And it has to look like a U. You can't make it look like anything other than a U, otherwise it's not a parabola. And that's it for finding the attributes by hand.